So I am not going to teach you how to code. You know that. I'm going to teach you the mindset, how you proactively think and try to code it. Okay. If you understand at least this searching, definitely will be able to decode most of the things by your own in my next video. Hello all, welcome back to Uncommon Geeks. Myself Vasant. I hope you all doing well. As soon as this is a video series where we're discussing about data structure and algorithm in JavaScript, I've already explained in the introduction how this series is going to be and what is linked list, and I've also shown basic operations of linked list in my previous video. In case if you've not watched those videos, I'll try to put that link on the screen also in description section. Please watch, because without that, if you come directly, this video will be utter waste. You'll not be able to cope up, because I've already written adding element to linked list, printing the elements of linked list, etc. Correct? So please watch the videos, then you can continue with this video. Now, for those of you who already watched my two previous videos, in this video we already know we have added the elements and we have displayed the elements. Correct? Now the third most basic operation is searching. Searching can happen in two ways. One, searching an element, and searching the element at an index. Correct? Both the searching I'm going to show you in this video. Okay, but before we start coding, let's go back and first look at the single linked list structure. Correct? So this is our basic. So I am not going to teach you how to code. You know that. I'm going to teach you the mindset, how you proactively think and try to code it. Okay. If you understand at least this searching, definitely will be able to decode most of the things by your own in my next video. That is removing elements. Okay. Now, if you see, so the, searching like I mentioned, let's start with basic searching, whether at element or at the index. First thing, what is the possibility? Head could be null. So in that case, the element doesn't exist because the linked list itself is empty. Correct? In that case, directly we can return -1. The next scenario is, you can in case of searching an element from an index. Correct? If you send an index in negative, then we'll not be able to give you any value. If you send an index beyond the last value, correct, whatever the element, then also there will not be any value. Correct? So those are two things. If you are trying to send an search by element when that element doesn't exist, then also will not be able to send anything. In all the cases, I try to return -1 whenever the head itself is empty, false wherever we are not finding to time getting we are getting the elements. Okay, so let us now try to decode the logic. So what is happening? So it's a linked list. All one node is connecting to other node. There is no way where we suddenly going to a node and see whether it exists. So can we do the binary search? Yes, if the linked list is sorted. Otherwise you have to sort it and do. It may save some time, but not too much like an array. Correct? The easiest way is, let's do a linear search where we go element by element and try to find where the element is present. Correct? So what you do, you already know how to traverse the linked list. You just check whether in that particular index the element present, or that element is present in the current node. That's all. Correct? I think most of you would be thinking, if you watch my previous videos, let's start coding. So you can code along with me, and in case if somewhere you feel confident, try to stop video, code on your own, come back and check whether the code whatever we both have written is matching. Okay, now let's first start by search element. Okay, comparatively easier one. For those of you who have not watched my previous video, I've clearly decoded how the how linked list is not as linked list in other programming language. Linked list in JavaScript totally different. How it is represented in object. Okay, if you're not know, please watch my first and second videos. Okay, now in search element you have to pass an element. Correct? So do I have a trace of it? Yeah, let me delete. So these are things that I was practicing to make sure I do the right coding. So here I have a search element. I'm passing the element. Okay, now you know the process. So same as the add element. So if head is null, okay, that means there is no element, then there is no way we can search. So you're returning -1. Correct? Now in case if the element no, there's only two ways actually. This is not on index, right? So now what we are going to do, so what we'll be doing is let current, same maybe that also we can copy from here. Let current this dot head while current dot next. So this is one way, I think, kind of a similar step that gonna be for most of the logic that we'll be writing. Okay, now so here what we will trying to do here is, so we are iterating. What we need to do now is, if so current dot element is equals to element, that's it. Correct? So return true, it present, otherwise outside the while return false. So simple. Correct? So what we did, I'm going to explain once again. Correct? So if I go back to the sketch, let me select this all and delete. So basically we have, if I have to draw in very simple words, we have one node, correct? We have one node, correct? Where we have a value of 10, let us say, correct? Next we have another node with a value of 20, correct? Next we have another node with a value of 30, correct? So what we are doing, we are trying to iterate this, correct? So head is pointing to this, correct? Head is pointing to this, correct? Head is pointing to this, and this is linked to this, this is linked to this, correct? So now what we are doing, we are trying to first come to this node and see, this is, as you know, this is an element field and this is the link field. So if I had changed my crayon color, so color, let me make it green, okay? So if you see, so this is a link, correct? So this is a link and this is the link. So every node has a link field or the next property to navigate to the next node. It also has a value. All we are doing is go to the node, compare its value with a value passed. If it is yes, return true. If it is not present even in the entire list, by default we'll send it as false, correct? So inside here, if you see while current, so here I am returning true. As you know, as soon as you return, the execution context is ended, control will go back from this code. So no longer the while loop will run. If this condition never became true, then definitely the value doesn't exist, so we return it as false. Let's see whether it works. Okay. So, log ll dot search element. Okay, we have 10 in the this one, correct? So I'm sending 10. Let's see, 10 is present, correct? Let us me send 30. 30 is present. No, 30 is not present. Why it is coming as not present? In fact, to show you only, I am doing this. Okay. See, we are doing current is equal to current dot next. So while of we are doing current dot next. If you see in this example, so this is null, correct? In the last case, this is null. What is happening? While is not running this one because the last node is null, correct? So whenever you are doing some operations, you shouldn't run current dot next. You should just run the current. Current anyhow becomes null at a point, correct? Even in the last node, the value should run. So if you run now, now also it came empty. Yeah? Let's try to decode. Okay. So LL search element, we are passing 30. Actually 30 is present. Yes, 30 is already present. That we can confirm by logging ll dot print list. Okay. So present, correct? Then we are going to do search element, correct? So now we are doing current dot next below itself. Current dot element is equal to element. We are doing return true, correct? And we are returning false here. The last one I'm saving. Let's try once again. Yeah, it's coming true. I don't know whether there was a mistake. I did not check it properly. So as you see, we are getting the true. So 30 is present. Let us send 100. Let's see if we get any error. False. 100 doesn't exist. Correct. So maybe let's not insert any values. Correct. -1. Correct. So all the scenarios that we discussed is covered in the program. So be mindful whenever doing the current dot next. Don't do it for the sake of doing. Okay. Run this object in your mind. So whenever you're hitting the last object, correct? Last object's next is null, but last object has an element, correct? So that has to be tracked. So due to which you are doing the while current and while not current dot next. Now let us do another search operation quickly. Okay. That is search at index. So you have to pass the index, correct? Again, if you go back to the linked list, the flow would remain the same. The index cannot be beyond negative. Index cannot be beyond the length of the linked list, correct? Index has to be some valid index in the linked list. Only then we can return. If head is null, again you return -1 because there is no index as such, correct? So all the basic operations of the previous code also remain same here. I'm copying this, correct? So if this is null, return -1, correct? This is also correct. And then, so somebody also used this concept where else if, so I use the size, right? So size, if index size is greater than this dot size, correct? So then also I'm returning -1. So either it could, in case if it is negative, that also you can do else if. So I mean, you can put all these checks. So I'm just adding few. Index is less than 0. Then also you will return -1, because negative index, so we cannot return anything. We have to only can return the positive indexes, correct? Now, if none of this, okay. So if none of this, then we are using the else. So where the operation is pretty much similar. So this, as I already said, is the same, correct, for a lot of things. So where here, if current dot element is equal to element, no. What we need to do is, here we need to keep a variable. Let LL index, so which means linked list index as 0. Okay. Then what I'll do, I'll be incrementing the linked list index. Okay, plus plus. What I'll do is, if linked list index is equals to the past index, correct? Whatever the index that we have passed, if they are matching, then return the element present in that, correct? That's all we are doing, because similar to what we did, rather matching the element, here we are matching the index. If index are matching, then return the value present in that index, correct? If nowhere it got matched, correct? If nowhere it got matched, then you will return false. So technically we are writing three states here: -1 in all the exception case, like when no linked list is present, or it is beyond the length of the linked list, or less than the negative number. We are returning the value itself whenever we are having the we have found what is the value in that index. We are sending false whenever there is no value in the given index, or they have passed some index that doesn't exist in that kind of a scenario. Okay. Or to avoid, we can keep -1 here only, to just two states, whether you return the element or -1 in all the extremities. Okay. I don't know, let me just check again is whether I've written all correctly or not. LL index, let me run probably, then probably we'll quickly come back and see. Okay. So search element, no, search at, is there a search, what I gave the name for it? Search element, search at, correct? Search at, let me give 0th index. Okay. If I print search at, I'm just commenting this to avoid the confusion. So search at 0th index is 10. Let's see search at the 2 index, which should be 30, correct? 30. Search its 200 index, it should be -1 as the index doesn't exist, correct? It should be -1. Let's say -10, where doesn't exist that index, -1. Okay. Or same again, let us confirm by not having any values in the linked list, correct? -1. So basically we kind of covered all the two basic search criteria. One with searching at index, another one is searching the element. So both are covered fine, correct? So now if you see how easily we did it, correct? All you needed to understand is this object structure and this while loop, correct? Now in the next video, whenever I do removing an element from index, that is slightly complicated because of some operations, but you will be able to do it very easily, I'll guarantee you that. Okay. So practice this maybe 3-4 times, this entire structure, be familiar with this block, then all the linked list operation will be very easy for you, I'll guarantee you that. Okay. If you like this content, please like this video on YouTube channel, so when more people like this, will be prompted to so many people, and I'll become popular, and moreover the video will become popular, and so many people will be able to get this important knowledge. So do not forget to share these videos with your friends, and please subscribe to Uncommon Geeks. So that will truly motivate me to make more good content. I'll add this entire code into my GitHub, so you can download it from GitHub project. Link will be in the description, and you can also practice the questions, all these on your own. Okay. Thank you so much for watching. Catch you in next video.